Right, to work out what we call stationary points on graphs is to work out where graphs do this, where they are flat. So they could be a local maximum, so where it peaks, or a local minimum, where it comes to the bottom. There's other special ones called inflections, but for IGCSE you don't need to know about stationary points of inflection. So we're just going to concentrate on maximum and minimum types. And basically what we should realise is that the tangent at these 2 points is flat. So therefore dy by dx will equal 0. The gradient function is equal to 0. Or if you're dealing with f's, it's f dashed of x is 0. So we need to work out the gradient function. So the gradient function for this, we're going to differentiate y equals x squared plus 2x times by the power 2, take 1 off the power gives me x to the 1, plus 2x just goes to 2, and the 4 number on the end, remember, has no effect on the gradient. So we've got dy by dx is equal to 2x plus 2. So we want to find the stationary points. Well, remember what I said? The gradient function will equal 0. So that means that 2x plus 2 will equal 0. So minus 2 will equal 2x. So x will equal minus 1. Now how do we find the y value? Well, we put it back into the original equation. That's how we find the y value. Y equals minus 1 squared plus 2 times minus 1 minus 4. So that's going to give me 1 minus 2 minus 4, which is just minus 5. Next one. So we want to find the stationary point for this one. So remember, we've got to differentiate first. So differentiate that, we get 2x. Minus 5x goes to minus 5, the plus 3 goes to nothing. We want to solve this equals to 0. That's where the stationary points are, where this thing equals 0. And we can see that 5 will equal 2x, so x will equal 5 over 2. So we can write in our answer to the derivative, and we can write in our x coordinate. Remember, our y value is given by the original equation. So we're going to put y equals to this x value here, 5 over 2 squared, minus 5 times 5 over 2, plus 3. 5 over 2 squared is equal to 25 over 4, minus 25 over 2 plus 3. 25 over 2 away from 25 minus 25 over 4 will give me minus 25 over 4. So what's that? That's going to be minus 6 and a quarter, plus 3 is going to give me minus 3 and a quarter for my y value. Do another one. Okay, differentiate this. So we get dy by dx, because we've got to find where the gradient is equal to 0, equals, the 3 goes to nothing, minus 2x goes to minus 2, the x squared goes to minus 2x. Remember, we're going to make that equal to 0, so we get this equal to 0, so we get 2 equals minus 2x, so x equals minus 1. So when the dy by dx, when the gradient function, I've made that equal to 0, when it equals 0, we get x equals minus 1. Now we want to find the y value out. Okay, so let's put it into here. So we get y equals 3 minus 2 times x is now minus 1. Minus 1 squared. Remember to put brackets around the negative, because minus 1 squared is 1. Minus 2 times minus 1 is 2, so you're going to 3 plus 2 minus 1. That will give you 4. And you get a y value equal to 4. Okay, we need to multiply out the brackets first before we can find where dy by dx equals 0. So let's multiply out the brackets, and we're going to get the first two things times together gives me 7. Then the outer two things is minus x, the inner two things 7x, the last two things minus x squared. Let's simplify that. So that's going to give me 6x minus x plus 7x minus x squared. Differentiate, because we want to find where the gradient is 0. So we get 7 goes to nothing, 6x goes to 6, minus x squared goes to minus 2x. Remember to find the stationary point. Remind you again, it's where the gradient equals 0. So make dy by dx equals 0. Just going to remind you of that fact. 6 minus 2x equals 0. So we've got 2x equals 6. So x equals 3. We need the y value. So we can put it back into here. So we get y will equal 1 plus 3, which is 4, times 7 minus 3, which is also 4, is 16. So our derivative was 6 minus 2x, our x value was 3, and our y value was 16. Just to remind you, this gives us the coordinates of where the gradient equals 0. That's what we've been finding. Okay, now we're going to find whether it is one of these, a maximum or a minimum. And there's a special way to find out where they are maximum and minimum. The first thing we need to do is find the first derivative is equal to 0, to find a 0. Then a max, we know that the second derivative, and I'll go on to how to find just second derivatives in a minute, must be equal to less than 0, i.e. negative. Okay, and for minimums, the second derivative is greater than 0, i.e. positive. Okay, now these seem to be contrary to what you might think. Maximum, the second derivative is negative. Minimums, the second derivative is positive. So that's all the facts you need to know to do these questions. So let's differentiate this. So we get dy by dx equals 2x plus 6. We want to find out where there are stationary points. So we need dy by dx equal to 0. And we solve that, we get minus, so I'm jumping ahead and doing too many lines. We get minus 6 equals 2x, so minus 3 equals x. We can find the y value, okay, by putting minus 3 in here. So y will equal minus 3 all squared plus 6 times minus 3 plus 5. So that's 9. Minus 18 is minus 9, plus 5 is minus 4. So we have a stationary point at minus 3, minus 4. But is it a maximum or is it a minimum? Which is it? Well, what we do is we find the second derivative. So the first derivative, we differentiated the first time, we got 2x plus 6. The second derivative, all we do is differentiate again. Differentiate 2x, you get 2. Differentiate 6, we don't get anything. So the second derivative is equal to 2. Now, is it negative? No, it's not. So it's not a maximum. Is it positive? Yes, it is. It's a minimum. So the second derivative is bigger than 0. So we have a minimum as our answer. So we say second derivative is greater than 0. Therefore, we have a min. Right, let's do one more of those. So we're going to find if this is a max, where there's a turning point or stationary point, and then we're going to find out if it's a maximum or minimum. So first of all, we're going to differentiate. 24 goes to nothing, minus 10x goes to minus 10. Minus x squared goes to minus 2x. I'm assuming by now you can differentiate. We remember stationary points are where this equals to 0. So 0 equals minus 10 minus 2x. So 10 equals minus 2x, so minus 5 will be equal to x. We can find the y value out by putting it into there. So we're going to get y equals 24 minus 10 times minus 5 minus minus 5 all squared. So this is going to be minus 10 times minus 5 is 50. Minus 5 squared is 25. Minus that is minus 25. 50 minus 25 is 25. Plus 24 is 49. So we've got a x value of minus 5 and a y value of 49 at our stationary point. Is it a max or is it a min? Well, we've got our first derivative is equal to minus 10 minus 2x. we find the second derivative. So write d2y by dx squared. This goes to 0. This will differentiate to give me minus 2. So the second derivative is less than 0. So therefore we have a maximum. Okay, so our graph must look like that. Now for GCSE terms, you can probably get away with saying, well, I've got an n-shaped graph because the quadratic is a minus x squared. Because we've got minus x squared, we know that we've got a quadratic, therefore we've got an n-shaped graph, therefore it must be a max. There's another way we could identify it's a max or min if you've got a quadratic. But that only works for quadratics. Okay, we've got a cubic now, so what we did just last time, and you notice it has maximums and minimums, because cubics can look like that, or, sorry, I'm going to draw the same thing again, or they can look like this, or actually they don't even necessarily have turning points. But as we know, is this question is going to have a max and a min, it's going to be one of these two. So first off, remember we find these where dy by dx equals 0. That's how we find them. Then we'll work out what type they are later. So dy by dx will equal 3x squared minus 6x minus 9. And now we're going to solve that equal to 0. So we have to solve the quadratic. Notice we can divide throughout by 3. So that's what makes our life a little bit easier. Then we can solve this by factorising. Okay, minus 3 times x and 1 times x gives you minus 2x. Minus 3 times 1 gives me minus 3. So therefore x equals 3 or x equals minus 1. But we need to find the y values. So we put it into here to find the y values. So when x equals 3, I'm not going to write out all the working, I'm going to talk you through it. So 3, well there's quite a lot to remember actually, I'm going to write down the numbers. So 3 cubed is 27. 3 squared is 9 times by 3 is minus 27. Minus 9 times 3 is another minus 27 plus 1. So that will give me, they're going to cancel, that will give me minus 26 for x equals 3. I don't know which one's which yet. X equals minus 1, my y value will equal minus 1 cubed is minus 1, minus 1 squared is 1, times by minus 3 is minus 3, minus 1 times minus 9 will give me a plus 9, plus 1. So they're going to cancel, so I'm just going to get left with 6. Now which is which? Well, let's look at x3, y is minus, let's look at 3 minus 26. Yeah, x is 3, y is minus 26. Well, first of all, I need to find my second derivative. So my first derivative was equal to 3x squared minus 6x plus 9. My second derivative is going to be this differentiated. So 2 times 3 is 6. Minus 6 goes to minus 6. 9 goes to 0. Now, notice I've got it as a function of x. So that means I've got to put the x value in for my turning point. And my x value is 3. So that's going to be equal to 6 times 3 minus 6, which equals 12. That is greater than 0. So therefore I have a min. So my minimum was 3 minus 26. So therefore the other one must be a maximum, minus 1, 6. Well, let's just check. Okay, my second derivative here is 6x minus 6. My x value here is minus 1. Minus 1 times 6 is minus 6. Minus 6 is minus 12. So at the point minus 1, 6, my second derivative will equal minus 12, which is less than 0, therefore a max, which agrees with our question. Okay, there's one more just like that, so let's just have another go at that. Just scroll down a little bit to give us more space. There we go. So, I've got y equals x cubed minus 3x plus 5. Let's differentiate that. dy by dx equals 3x cubed goes to 3x squared, minus 3x goes to minus 3, 5 goes to nothing. Remember, I find maximum and minimum when dy by dx equals 0. So let's make it equal to 0. Take 3, add 3 to both sides, divide by 3. Now, common mistake is just to write x is 1. It can also equal minus 1, because minus 1 squared is also 1. So every time you have x squared equals something, remember it's plus or minus that value. Now we want to find the y values out. So x equals 1. Let's put x equals 1 into our equation. So we're going to get 1 minus 3 times 1 plus 5. So that's going to be 2 plus 1 is 3. So we've got one value of 1, 3. When x is minus 1, then the y value will equal minus 1 cubed minus 3 times minus 1 plus 5. This is minus 1. This is 3. This is 5. So 3 plus 5 is 8. Minus 1 is 7. So which one is the max and which one's the minimum? Well, let's find the second derivative. dy by dx was equal to 3x squared minus 3. So the second derivative, differentiate this again, is 6x, and this just goes to 0. So at the point 1, x is 1 and 3, my second derivative will equal, put 1 into that, I get 6. So that is positive, so therefore I have a min. Just check, and so therefore the other one will be a max, but let's just check. So at 1 minus 1, 7, because if it doesn't work, we know we made a mistake. d2y by dx squared, put the minus 1 in for 6, gives me minus 6. Therefore we have a maximum. So the maximum was minus 1, 7, and the minimum was 1, 3.